In Chapter 4.1, we're going to be looking at radian and degree measure. An angle is two rays with the same initial point. The measure of an angle is the amount of rotation required to rotate one side, called the initial side, to the other side, called the terminal side. The initial shared point of the two rays is called the vertex of the angle. An angle is in standard position if the vertex of the two rays is at the origin and its initial side lies along the x-axis. Positive angles are generated by counterclockwise rotation, whereas negative angles are generated by clockwise rotation. So if I have an angle that starts here, if it goes this way, that's positive. And if it starts here and goes this way, that's negative. When we talk about radian measure, we're going to draw a circle on an XY Cartesian plane with the center at the origin and a radius of 1. So this point here is at x equals 1, and here it is x equals negative 1. Because the circumference is 2 pi r, if the radius is 1, then in this case, our circumference is just 2 pi times 1, or 2 pi. So we're going to label this circle with 4 measures in radians based on the circumference of the circle. So at the first part, this is pi over 2. When I have gone halfway around, we're at pi, and then we are at 3 pi over 2 and 2 pi. This circle with the radius equal to 1 is called the unit circle. Angles with measures between 0 and pi over 2 radians are called acute angles. Angles with measures between pi over 2 and pi radians are obtuse angles. In radian measure, a full revolution counterclockwise is 2 pi, but in degrees, a full revolution around the circle corresponds to 360 degrees. A half revolution corresponds to 180 degrees. So, if we were going to label the same circle above, we would have 0, 90, 180, 270, and then back to 360 degrees. In order to convert degrees to radians, you take your given degrees and you multiply by pi and divide by 180. In order to convert from radians to degrees, you take your given radians and you multiply by 180 and divide by pi. So if I wanted to convert 120 degrees, so that is my given degrees, if I want to convert it to radians, then I multiply by pi and I divide by 180. So I'm going to have pi left in my answer, but that is 120 over 180, which simplifies to 2 over 3. So my answer is 2 pi over 3. To convert 9 pi over 8 into degrees, this is given in radians, so that is my given radians. So I start with 9 pi over 8. I am going to multiply by 180 and divide by pi. Pi cancels, and I am left with 9 times 180 over 8, which if you put that in your calculator, you get 1620 over 8, or 202.5 degrees. Coterminal angles are two angles in standard position, shown here with this red arrow, that have the same terminal side. So that means I could have a positive angle where I go counterclockwise from my 0 position, or I could go clockwise and I can get to the same one and I would have a negative angle. So depending on if I'm in radians or degrees, to find my coterminal angles, if I am in radians, I add 2 pi or I subtract 2 pi. I could also, if I am in degrees, add 360 degrees, or subtract 360 degrees. So let's look at how to do this in example 3. So we're going to find two angles that are coterminal with 43 degrees. So in order to do that, we start with 43, and we are going to, because this is in degrees, we are going to add 360, and we're also going to take 43 minus 360. If it only asked you for one, you could pick either one. In this case, we're going to do both. So 43 plus 360 is 403 degrees, and 43 minus 360 is negative 317 degrees. For part B, pi over 4 is in radians, so we're going to be adding and subtracting 2 pi. So we do pi over 4 plus 2 pi, and pi over 4 minus 2 pi. Now, I have some fractions, so I've got to work with those. So this is really 2 pi over 1. So in order to make that over 4, I'm going to have pi over 4. Then I'm going to multiply by 4 over 4, so that's 8 pi over 4, which is in total 9 pi over 4. And then if I'm going to subtract, I still have to have common denominators. So it's going to be the same thing, except now a minus. So it is pi over 4 minus 8 pi over 4, and 1 minus 8 is negative 7 pi over 4, and those are my two answers. To find the complement of an angle, we want to find the angle that when it's added to my original angle, it adds up to be 90 degrees. So if we're working in degrees, the complement is 90 minus the given angle. But if I am in radians, the equivalent of 90 degrees is pi over 2, and then minus the given angle. To find the supplement of an angle, we want to get to a total of 180 degrees. So if we are in degree mode, we're going to be taking 180 minus our given angle. And if we're in radians, the equivalent of 180 is pi radians, and then minus our given angle. So what that looks like when we solve problems to find the complement of 54, so we're going to call this C for complement. This is in degrees, so we're going to take 90 minus my given angle, which is 54, and that gives us 36 degrees. Our supplement is going to be 180 minus our given angle, which gives us 126 degrees. For B, we are in radians, so to find our complement, we're going to use pi over 2 minus our given angle. Now, in order to do these, we need to have common denominators, so we're going to have to do a little bit of manipulation here. So I want my common denominator to be 6, so this one's going to be 3 pi over 6, and this one is going to be 2 pi over 6. So 3 minus 2 is 1, so that equals just a single pi over 6. And then for my supplement, I'm going to take pi minus my given angle of pi over 3. So a single pi is 3/3 times pi minus pi over 3. 3 minus 1 is 2. So 2 pi over 3 is my supplement. One of the things we need to be able to do is find the arc length of a portion of a circle with a given radius. So arc length is S, R is the radius, and then theta is going to be the angle in radians. Make sure you are working in radians, and you'll want to memorize this equation. So in example 7, we're going to find the length of an arc that subtends, so that means that's this one right here, a central angle of 42 degrees in a circle with a radius of 8 centimeters. So we're going to use our equation, S equals R theta, but I need to be in radians. So what I need to do is I need to take 42 degrees, and I need to convert that into radians. All right, and so when I do that, that's 42 pi over 180, which is 7 pi over 30. So now I can plug that into my equation. So that is going to be 8 for my radius, and then my angle is 7 pi over 30. And when I simplify that, I get 56 pi over 30, which if I put that in my calculator, it rounds to 5.86. And don't forget your units are centimeters in this problem. We can also use this equation to work backwards from an arc length and find out something about the circle. So when we do that, here, we're going to start with our same equation. The arc length equals the radius times the angle. And now we know that my arc length is 70.7, and that equals my radius, which I don't know, that's what I'm solving for. And then the central angle is 5 pi over 4. So now, in order to solve for r, I'm going to multiply both sides by 4 over 5 pi. So these cancel, and I'm left with r equals 70.7 times 4 all over 5 pi, which when I put that in a calculator, I get that r equals 18, let's see, our units are meters. And so in order to get from the radius to the diameter, I multiply that by 2, so my diameter equals 36 meters. Another thing we can do is find the area of a sector. So if, for example, I have an angle, I can actually find this area if I know what this angle is and I know this radius. And so the equation for that area, which is a capital A, is 1/2 r squared theta. And again, this is in radians. So in example 9, we're going to use this to solve a problem. So sprinkler on a golf course is set to spray water a distance of 70 feet and rotates through 120 degrees. We're going to find the area that that golf course is watering. So we're going to start with our equation. Area equals 1/2 r squared theta, but I need theta to be in radians. So we're going to pause for a second on the equation, and we're going to do that conversion. So 120 times pi over 180 equals 2 pi over 3. So now we can use that back in our equation. So that is just 1/2. R is 70, and we're going to square that. And then my angle is 2 pi over 3. So when I plug that all into a calculator, I get that it is 5,131.27 square feet. The final thing we can do is look at linear and angular speeds. So for example, a particle moving at a constant speed along a circular arc of radius r. So this is called circular motion when you study this in physics. So when you do that, the linear speed, v, of the particle is going to be the change in the arc length over the change in time. And so if you go around a full circle, that's just the circumference. The angular speed, which we use omega, the lower Greek letter, and that is going to be the change in angle over the change in time. And so that's another equation you'll want to know. So in example 10, we're going to be finding the linear speed, so we're going to use our linear speed equation, which is v equals delta s over delta t. And in this case, it tells us that we're looking for it as it goes around the clock face, so that's going to be a full 2 pi r, because we're going to be in radians for this. And then we're going to want time, which it gives us, as it's all around the clock, for a second hand is 1 minute or 60 seconds. So when I do that, that's 2 pi r over 60. In this case, the radius is 10.2, all divided by 60, which is just 1.07, and my units are centimeters per second. In example 11, we're looking at a Ferris wheel with a 50-foot radius, and it makes 1.5 revolutions per minute. So now we're actually figuring out, we have omega, and we're going to want to find the angular speed in radians per minute. So we know that omega equals my change in angle over the change in time. So in this case, if I make 1.5 revolutions, that is 2 pi around once, and then halfway around again is another pi. So that is a total of 3 pi, and that is 1 minute. So again, well, we want to stay in minutes, so we're going to leave this as 1 minute. And so when I put that in, 3 times pi is 3 pi radians. We want our units, especially since this would be a physics question, per minute. And then you could also put that in and call that 9.42 radians per minute. Either one of those is an acceptable answer. Now, if I want to know how fast someone's going sitting on a seat of the Ferris wheel, we're going to look at the linear speed. So now we're going to use our linear speed equation, so delta S over delta T. And in this case, it is 1.5 times around the circumference, which is 2 pi r, over our change in time, which is 1 minute. And so we're going to plug in 1.5 times 2 pi, and then r, our radius, is 50, and then over 1 minute. And so when I plug that into my calculator, I get 471.24 feet per minute.